Batteries are everywhere, from our smartphones to our TV remotes and even our alarm clocks. In the UK, we throw away 60 million batteries every single year. This equates to over 20,000 tonnes of batteries going to landfill. Should we recycle them? What stops us from recycling them? Let's take a closer look to what's inside them and whether we should. So we're all familiar with the standard form of a battery. However, if you're a science student, you might be more familiar with a diagram that looks like this. Down the centre of a battery, you have something called a current collector. A current collector facilitates the movement of electrons from the electrodes to the battery terminals. The anode then wraps around this current collector. The anode will be surrounded by an electrolyte with the cathode wrapped around the outside. An electrolyte is just a solution that carries a charge through its ions. Think of a battery simply as an electrochemical onion, which is just made up of different layers. You might be surprised on how easily we can build our own cell. Using everyday items such as coins, salt and vinegar, we can create what is known as a voltaic stack. A voltaic stack was the first type of battery to ever provide a constant electrical current to a circuit, and we're going to have a go at making our very own. First things first, we need to create our electrolyte for the cell. The electrolyte for this process will be a vinegar and salt solution. So what we want to do is stir in 1 tablespoon of salt into 4 tablespoons of vinegar. Keep on stirring until all of the salt has been dissolved into the vinegar. Then we want to add 5 1 or 2p coins and then 5 or 10p coins into our salt and vinegar mixture. The acetic acid within the vinegar will react with the salt to strip the metal oxide off the coins. While that process is taking place, you want to cut out 5 penny-sized discs. You want these to be roughly the same size as the coins you chose to use. After 5 minutes or so, remove the coins from the solution and then rub them dry with a paper towel. Keep rubbing the coins until they become shiny. The greater the shine, the less metal oxide we will have on the coin and the better the conductivity. You then want to soak your cardboard discs in the solution. This shouldn't take too long. Then we want to take them out and remove any excess solution with a paper towel. Now we have all of the items we need to start creating our own cell. So first things first, we want to place a cardboard disc on top of a copper coin. Then we want to add a silver coin on top, which are actually made of nickel-plated steel. This is the first element of our cell. We need 5 of these elements to create the entire voltaic stack. So to check to see if we're going to get a voltage across our cell, we're going to use what's called a digital multimeter. So we want to add 1 across there, and the other across there. And then we can see that we're getting 0.55 volts from our cell. So why don't we use voltaic cells to power everyday items? Well, the issue is they don't give us the power requirement we need, and they don't provide it for a long enough time. So therefore we need to use other useful compounds such as lithium to provide a battery with greater electrode potential that can provide us with a greater voltage. So what happens to our batteries at the end of their lifetime? Well, quite often they end up in landfill, where harmful chemicals such as lead, acid or nickel can leak into the environment and poison our water systems. If you think back to our demonstration, you wouldn't throw the money that we used to create the cell away, so why would you throw away the valuable metals that are in the batteries? This is why it is crucial to recycle our batteries and not just send them to landfill.